Okay, so now we're going to talk about inductor. What is an inductor? An inductor is a circuit element used in DC and AC circuits. It consists of a coil of a wire wound around a magnetic core. Okay, so an inductor is a passive device which can temporarily store energy in a magnetic field and use this energy back in the circuit whenever required.
Okay, so what happens when an inductor is placed in a DC circuit? When an inductor is connected to a DC circuit, it initially opposes changes in current, but after approximately 5 time constants, it does not present any resistance to the current. So the EMF generated in the coil given by the equation E equals to negative di over dt, this opposes a source voltage and prevents any current flow. Okay, so now I'm going to talk about the background of an inductor. Current through an inductor induces a magnetic field with flux lines leaving at one end and coming back at another. The properties of an inductor determines the strength of magnetic field around the coil due to the applied current. The magnetic flux is a measure of the magnetic field running through a loop of wire and determined by this formula. Okay, according to Lenz's law, the direction of the induced EMF opposes the change in current. The size of the EMF is proportional to the rate of change of magnetic flux. So now I'm going to talk about the formula of an inductor. The EMF induced in an inductor is proportional to the rate of change of current. The proportionality constant is given the symbol L and is called inductance. The value of the inductance is determined by the size of the coil and its core material, summed up in the equation. Okay, so now I'm going to talk about the voltage through the inductor. The voltage across an inductor is represented by the following equation. Okay, where the value Lr is known as the time constant of the circuit. As seen from the graph, the inductor voltage decreases to approximately 0 after 5 time constants. So now I'm going to talk about the current through the inductor. The current in the inductor is represented by the following equation. Current does not instantly change, it always lags by a certain amount of time. As seen from the graph, the current reaches its maximum value after 5 time constants. The final value of the current is E over R, as the inductor does not present any resistance after about 5 time constants. When inductors are connected in series, the inductance increases, meaning when inductors are connected in series, the total inductance equals to the sum of individual inductance. And now I'm going to talk about inductors in parallel. When they are connected in parallel, the inductance is reduced, meaning when the circuit have more than 2 inductors and connected in parallel, then the total inductance is determined by the following equation, where